And I'd like to welcome, without further ado, Jeremy Kemper.
Thank you, David. That's very kind of you. Nick, that was really cool seeing what JRuby is up to these days. It's really interesting having put all this work into 2.2, and is there a little feedback going here? And then seeing the fruits of it. JRuby is one of the only Ruby implementations that can really take advantage of all the thread safety stuff that Josh Peak has been doing. We've seen a lot of other benefits, mainly in code quality. That's interesting for its own sake, but to actually see it live in deployment is really exciting. And I thought about talking about Rails 2.2. At RailsConf US, I talked about 2.1 and all the work we had put into it, and it had been a little while since 2.0. And it was a pretty significant release. And 2.2 is kind of in the similar vein. There are a lot of things changing, but most of it is under the covers. There aren't any big new things, paradigm shifts in the way that you actually write your applications. But there are a lot of little details about the way that Rails works that are changing, mostly because of Josh Peak and Pratik. We're very happy to have on core now. They've just been kicking ass all summer. But I decided to talk about something I've been working on a lot more recently. It's performance. It's often considered kind of a dirty word, especially in the web app community. And when performance is impugned and somebody has to compare performance, it ends up being a pissing match. And you look at the way one framework works versus the way another framework works, and it really all boils down to just sending web pages. And you're getting an HTTP request. The application has some behavior and sends a response. And there's so many different ways of doing that you end up boiling down the difference between web application frameworks to these details about how it does it. It's interesting, but it's a lot more interesting to me when it actually comes to play in a real application. And this is what we saw in Basecamp. The first thing I have to ask is, what is a performant application? It can really mean almost anything. It can mean anything you want. It depends on the audience. If you're a programmer, sometimes it can mean the speed at which a request is rendered. If you're a designer, it could be the tools and the styles available to you to most quickly get the look you're looking for. But ultimately, if you're a user, that's what matters. It's what the applications are for. The performance of the application is to drive the user experience. And really what that boils down to is the snappy. When a user's browsing a site, it's that quickness. It's the ability to have something respond, and that feature is right there. You aren't waiting around. And so to the user, you aren't really thinking about what performance means. To the user, you're only aware of what performance isn't. You see that something is slow, and that just becomes a sticking point for your application. And of course, the common refrain, premature optimization. You always have to ask, if you start going into this, is it something that you really need to do? There are often other things you can do, and the typical choice is to throw hardware at the problem, either more hardware to scale or faster hardware. And the difficulty will be if you know that say your Mongrel pack is at capacity, you're going to see yourself losing performance just because you don't have the resources available. But say your Mongrel pack is not at capacity and you're still seeing long page load times. Well, what do? I mean, you can get a faster CPU, but you can't beat Moore's law. If you want a 5 gigahertz CPU because you want to speed up your application that much, you just have to wait. And sometimes you can't. This is the situation we're in when we look at how an application performs. It's a dearth of information. It's just we're in the state of poverty. We don't know really what's going on with the internals of an application all the time. People end up guessing and making kind of wild claims about what really matters. And we're lacking the tools for a long time to really drill into an application and figure out how to measure that performance, that actual user-centered performance. But luckily, we have some great folks like, this is the slide. And this is what we end up looking at. This just doesn't tell you very much. if you look at the log file and you have some specific timings for these database calls, and then just saying that something was rendered, and then a global kind of aggregate time. And just the fact that this is the only information available means that this gets the focus. If all you can see is that your database calls have any time, that becomes kind of a database optimization issue. It's missing the other kinds of data you need to really optimize your application. But then we pull up the net tab in Firebug, and this is what we see. The application is that little bar up there in the top left. And all this other stuff, this is an actual page request, and you can kind of see the effect of the slow network here on all those assets loading. But the fact is, this huge ocean over here is going and swimming in the web. And that tiny little bit up there is your little life raft of your application. And if the first answer you have for your application is that I need a faster CPU, or I need to go dig in and optimize my algorithms or something, well, I mean, look at that. It took 4.38 seconds to load, and the application was 329 milliseconds. So it would really not be an efficient use of our time to try to speed that up right now. And the best thing to do would be look at these bars, and why are they mismatched? I mean, some of them are way over to the right. Why did that take so long? Why did some start right at the beginning? And why is there a pause between the application load and the next asset load? It just turns into this question of how does the browser actually work? And it just becomes kind of a mystery to everybody until somebody actually figures it out. And this is our little voodoo doll of actually trying to see how a browser works. If you try to understand how the caching inside a browser works, you often have to go look at the source code because there's no documentation for this stuff, and it's somebody who decided to implement caching in a certain way. If a content length header isn't returned in the right manner, then caching can be turned off. Well, it's just like having to deal with CSS or JavaScript differences between browsers. Trying to make your application cacheable and browser friendly can be really difficult. But luckily, this guy, Steven Souders, came along, and was the chief performance dude at Yahoo for 6 or 7 years. He's now at Google. And he came up with this list of rules, kind of common knowledge and best practices that they extracted from their work at Yahoo, and he's now doing at Google. And he came up with this kind of a pablum for saying, if you follow these things are going to they're going to hit all the top points on making your app load faster in the browser. So it's really optimizing the application for the browser. And you can get this YSlow addition to Firebug. It's super useful. It lowers the barrier to entry to understanding what's really going on, how your application is interacting with the browser. And the way it does it is just by giving you a straight up kind of report card of load your application. I'm going to analyze, and I'm going to tell you whether you really screwed up or if you did a good job. And so you can look at each of these things and see what your grade is. And here, okay, I'm not using a content distribution network. Okay, I get an F. So that brings down my total score. But overall, it's looking pretty good. And we're not using too many HTTP requests. Typically, something you'll see is a bunch of link tags up in the head element. And that's for every CSS file. It's for every JavaScript file. It's for your RSS feeds. But typically, it's CSS and JavaScript. Every single one of those, you have to go out and hit the server. And especially on a high latency connection, every one of those HTTP hits, that's a three-way TCP handshake. And so as the latency increases, it's just going to get worse and worse. And the user experience is just horrible. And we see this in the US, especially on SSL connections, people connecting from, say, Australia, where you have high latency. And the only way we can really see that is by running a transparent proxy with our own applications and trying to simulate that. Charles is a good option for that. You guys can all try it. It's really quite stunning looking at your own application through the lens of somebody who's far away. And you're going to be hard pressed to get somebody to use an application when you have 3-second page loads for what ought to be just like that. One note I have about YSlow is it's really aimed at public sites, and this is one thing we see here with I've got an F on the content distribution network. It's really critical for a public site because so many of your page loads are on that very first load, and on on a site where you have users and accounts, which many of ours do, it's not as crucial to be super, super cached as, say, Yahoo's front page. We can step down through a few of these. I mean, a lot of them we're already familiar with. Having an expires header. This is, it's simple stuff. It's just saying that you want your assets to live for a long time. You don't want to fetch them every time. And Rails already supports this. If you put an expires header on your assets, all your assets are time-stamped. So when you modify them, that timestamp changes, and it's essentially a new asset load. So those old ones are sticking around, expiring 10 years from now, but who cares? Now the browser's seeing the new one, and it's quite effective. gzip, another one that affects your first page load very heavily, especially if you're using a larger JavaScript library like Prototype. If you look at Facebook's JavaScript, and they're over a megabyte now of JavaScript. And so compression is just absolutely vital for something like that. Even on a fast connection, that kind of JavaScript load is going to cause some noticeable lag. Another that, well, I guess I would fold into the fewer HTTP requests is asset caching. And it's really kind of batching. The way that if you have 10 style sheets up in your head element, you can actually combine all those together into a single style sheet, and that's also just built into Rails. So we'll step through a few more of these in a bit. Really, the simplest way for number one, do fewer HTTP requests, is just to do less. And if you have a really image-heavy site, if you have a really asset-heavy site, sometimes you can just cut some of that stuff out, and sometimes it's just extra stuff. And you don't have to worry about speeding up stuff that you don't need. And that might just seem like a kind of a pat answer to the problem, but I mean, it's always one worth considering before putting in further work. Cutting stuff out is always less work. So here we have the asset bundling. It's going to look at every single style sheet in your public style sheets folder, combine them together on the first request, and every subsequent time you only have to serve that single file. And it's just, again, especially on a high latency connection, you can notice the difference so quickly. This isn't actually, it's in Rails, and people kind of need to find out about it because it's not generated into your application. So if you're just kind of running with what you start with your kind of default layout, you're not going to be taking advantage of this. So it's worth checking and seeing whether you're using it now. The other one expires. These are Apache examples. If you want to set expires on all your assets, I'm saying that after you check it, I want the expires header to go to 10 years. So hopefully that's going to stick around in the cache for a long, long time. One small note, if you're using SSL, this is getting into the browser voodoo again, it won't store it after you quit the application, after you quit your browser. And of course, this is for security reasons. If you're browsing an SSL site and you've got a graph of your historic returns on your super secret investment or something, you don't want that sitting in the cache on your computer. But on the other hand, it would be really nice to be able to kind of override that for certain things, because otherwise, if you do have users on SSL connections, you're hitting that first load phenomenon far more often than if you aren't. Another little detail, more voodoo. Firefox does not support having non-SSL asset loads, but Safari does. So you can actually play around with this a little bit, where if you can tweak your asset host to use a non-SSL connection if you're on the Safari user agent. And so this really starts getting into that territory of the funny hacks in CSS to just do stuff for IE7. When you start looking at user agents, and it's feeling pretty ugly. But it's often worth it, especially if you have a lot of people on SSL. Another is really taking advantage of all that caching of those assets. And one thing we noticed was just kind of silly. We're looking at asset loads, and sometimes the E tag would change. And the E tag is just this little identifier that uniquely says that piece of content you're serving, whether it's an image or a JavaScript file or a CSS file, it's the same. It's what I already served you, and you want that E tag to always stay the same. Well, if you distribute your assets across a web cluster, Apache by default includes the inode of the file in the E tag, and so you'll get different E tags on different Apaches in that cluster, which means that sometimes you're getting the whole asset sent back when it really doesn't need to be. Sometimes you're getting 304 not modified back, which is really what you want all the time. And so this is something that's was kind of a silly oversight, just having to look at in Firebug and see, like, why am I getting a 200 OK response to that? This just doesn't make any sense. Well, it turns out you can just go into Apache and tell it, don't use the inode for e-tags. And apparently this is, I searched around on the web, and lots of people kind of know this, but it just, I don't know, it never entered the mainstream consciousness that I'm a part of. The other is asset hosts, and this actually isn't mentioned in YSlow. Maybe, I don't know what they're doing at Yahoo. They actually do some tricky stuff with separate domains. They don't have to send cookies and all that, but more browser voodoo, there are only 2 connections per host on non-SSL connections, non-keep-alive connections that you can reuse. So this is a workaround to get your browser to open more concurrent connections. So if you remember back to that original loading page, that net tab, when you see certain requests and the main HTML page is loading, but then way over here an asset's loading, and then way over here some more are loading. Well, that's because they're loading in batches. It can only open so many connections, and so you encourage it to open more, so it tries to load more of those assets in parallel, rather than serializing them all. JavaScript poses a huge problem for an actual page render. As you render the page, say you encounter a little snippet of JavaScript, well, it's going to block the page render while it's executing that JavaScript. And especially if you're including JavaScript inline. For every single one of those times you execute JavaScript, say it's a bunch of list items, well, that means you're blocking the page on every single list item. Using something like unobtrusive JavaScript or asynchronously loading that JavaScript means that you can at least render the whole page, then add behavior as kind of an overlay. It's something that's, it's a matter of interaction rather than what's really needed to render. So if there's any way you can split up your JavaScript so you can just load what's needed to render in the beginning, just block that long, then render the page, then show your JavaScript. There are a few other tricky scenarios with CSS where if you include inline CSS styles, then it will actually block parallel asset downloads, so your asset hosts are just kaput. And you don't really, I can't really say much about that because I haven't figured out that voodoo yet. I mean, when it decides to do it and when it decides not to. And who knows? And we can do all this stuff now. And all the tools exist. Some of them have been talked about. There's the unobtrusive JavaScript tutorial. And so you can actually employ all these techniques already. And so if you're looking at that page load time, those 4-point-something seconds in this admittedly kind of a harsh case, if you're looking at where you can spend your time, if you can get a 50% speed up out of your application, you've saved the user, say, 10%, 5%. And that's really negligible considering the amount of work that you'd have to put into doubling the speed of your application. That's massive compared to the amount of time you put into doing these little tweaks to get your application to behave better with the browser. And of that 300-something milliseconds, you had 4 seconds of just asset loading. You cut out 50% of that, that's 2 seconds. And it's far more, it's better return on your effort. Here's some links to the rules. Steve Souders actually has a book called High Performance Web Services now. I don't know the guy. I don't actually own the book either. No royalties coming back to me. But his rules are really, they're quite impressive because you can use it as a cookbook without really needing to dig into all the kind of arcana of how the browsers work. And you can just go down the list one by one, and you're going to see your web application performance improve just each step of the way. But, okay, so we've done these things. We've done these things in the meantime here. Say you're on the second page load, where you have all those assets and they're already cached. You've loaded your HTML page, and, well, now you're down to just that one hit to your Rails application. And now it's a little more interesting because this is kind of more in our comfort zone, where we're dealing with an application. These are tools we know. And we really want to dig in and get our app going fast. Well, here we are again. I know that 329 milliseconds. I mean, how are we going to break that down? I mean, what does that mean? How can we tell where that time is going? Well, we really need to identify what is slow and what's fast about the application. And there haven't been many tools available for this. And there's some kind of ad hoc things you can do. Like we include an x-runtime header. If you look in Firebug at the response from any of your Rails applications, you'll see x-runtime. And it's the same time you see in your log files. So you don't have to go inspect your logs to see if you're on a slow page. You can actually check and see whether it was slow because of Rails or because of the web. X-runtime is going to tell you it took 112 milliseconds, whereas Firebug or Firefox is telling you that it took 800 milliseconds. Well, you can account for that difference because Rails is at least telling you where the time went. But this doesn't really scale. This means that you're looking at individual pages as they occur. It's hitting things, stubbing your toe and saying, "Ow, what was in the way?" Rather than turning the light on and just avoiding it. And so this is where we get to kind of a bigger topic. And this is a few companies have just started releasing products that instrument Rails itself and your application so you can see what's happening. It's not just seeing what's happening on a single action or in a single case. It's seeing what's happening in your whole application and a history over time. So you can identify how things are changing when you make a code improvement. Did things improve? And without measuring, you can't really know. One I've used a lot is New Relic's Rails Performance Monitor. It's actually driven a lot of the changes that we made to Basecamp. There's some very basic things it provides and kind of a prescient user interface. Being able to look at things like how much total time is being spent in the application. Just aggregate that for me. And it just becomes a really nice, simple way of seeing that. I've kind of excluded some info for, but you can look here at the top bar. I mean, there's my biggest time consumer. I mean, obviously, there's my marching orders. I don't need to ask, what am I going to stub my toe on next? Because here it is. Okay, so I've got number 1, and then number 2 is the kind of yellowy one, and number 3 is the green one. Okay, so that's what I'm going to work on in kind of my next little performance sprint, and then we'll call it done. Another thing is call volume, able to see over the application. This is for actually a time period this morning on Basecamp, looking at how often those pages are actually called. This is a really good way of getting a sense of how your users are browsing the site. You don't get a sense of kind of the direction they're taking, but you can make a synthetic benchmark of your own to weight actions in the application according to the way users browse them. So if you look up here on the top, that one it's more than twice as often visited as the next most. So if I'm going to be doing some benchmarking or profiling, I'm going to weight all those page loads according to this graph, essentially. I'm just going to pull it straight from there. And so then in my profile results, I'll be able to tell what matters on aggregate in the application across all these actions. So you can more easily identify the things that you can change that will make the biggest performance difference across your application as a whole rather than a single action. Another aspect to this is call volume it's an indicator of resource consumption and contention. So if you're looking, the top item here is actually an RSS feed. And it's something that a lot of people are employing, so you're going to see that at kind of constant load all the time, day and night. Whereas the rest of the traffic is going to kind of dip at night and go back up during the day. Well, that constant traffic is eating mongrel time. And this is something where it plays into what Nick was just talking about with concurrency and thread safety. And if you're eating that mongrel time, it means that even if you have a fast request, it's consuming a mongrel for that time period. And that means other requests are waiting around a little bit. And so if you speed up that very common but maybe already fast request, you're freeing up mongrels for all the other slow requests. So by speeding up that one, maybe already quick request, you're going to indirectly speed up your whole app. So what do we do once we've identified these things? We've got our marching orders. We've got number 1, number 2, number 3, the things to do. Well, we still have this kind of opaque idea of the application and what it's actually doing. We need to somehow get in there and measure what's going on and what makes sense to do. And we need a battle plan. Not so all these warlike metaphors. It's really more of a soft and fuzzy process, but. This is 5 runs, has a nice little free product, tune-up. You install this plugin, and it gives you kind of a coarse-grained profile of the action that you're loading. So you can see how much time is being spent in the model, the view, and the controller, and this kind of like nebulous other. And so it's a good way of at least identifying where to start looking. If you see that, well, I mean, most of the time is being spent in the model, and that's typically very uncommon. Especially for your read requests. I mean, obviously, if you're creating, you're posting a comment or something, those inserts are often going to take some time. But if you're doing selects and you're seeing that it's taking the majority of the time, something's going wrong. And so, thankfully, those are often the easiest things to fix. If you have a database problem, I mean, it's either indexing or you're doing just a stupid number of queries. But these are also the things that you're going to notice first. At that very first step, looking in the log file, you would have noticed those queries and you would have already solved them. So you probably wouldn't get to that step. Other things, and you're typically going to see most of the time spent in the view. And so in TuneUp, you can kind of drill down through the view and see what is actually happening, rendering partials, doing finds within those partials. And what you really want to hone in on is kind of the biggest branches you can find. And it's often easy, and if you're using a profiler, to look at the things that have the individual methods that have the greatest time consumption. And that's not going to be very useful, because you're going to see things like hash access. Well, what are you going to do with that? I mean, you're going to try to go through your application and cut down on hash accesses. And that just, there's no directional power there. It's not telling you anything that you can actually do right now to speed up your application besides this vague, like, wow, Ruby really hits the hash a lot. So there's this tool that debuted with Rails 2.1, script performance request. And it's essentially a profiler for an integration script. And so you write a little script, a .rb file, that you use the same syntax you would in an integration test. So you can do something like log into your application, go browse some pages, or even do kind of a weighted browse. Like if I took that page volume graph, I'd feed that into an array or a hash or something of the weighted page volumes, and then loop through that and just do those hits. And it doesn't have to be very complicated. It's just getting kind of a broad sense of what the application is up to. So I used this for a little while, but the difficulty with it is that it's so ad hoc. I ended up with just this junk drawer and I was thinking about legacy code, and this seemed so cool when I first did it, but then after a week or two of really heavily using it, I was already getting disappointed. Because I had this one directory that had tons of .rb files, and it's just, it can't really make much sense of it. Plus, you end up with these results, and what do you do with them? And you have no sense of time or scale or context or whether you've improved or regressed, and that's a big one. How do you know in the future you've done all this performance work, you've shaved some time off your application and put days of work into it, except then later, some tiny change sneaks in and you take a step back. Well, with unit tests, we can see that the application behaves correctly, but there's no real equivalent for seeing that your application is performing up to par with where it was before. So we took a little bit of a different approach. And we introduced performance tests. So in Rails 2.2, applications by default will have a performance test suite. So it kind of takes the idea of these one-off integration tests, performance tests, and really institutionalizes them. It turns it into kind of a testing habit, the way that it is with unit and functional and integration tests. And when you run your test suite, you're actually getting a history of your performance. And so currently it dumps into a CSV file, and you can see, let's see here. Well, it's just, yeah, so this is an example, and let's just go straight to this. It's pretty simple, and it's, There's a generated version. If you're on Edge right now and you generate a new app, you can see a stub that's very similar to this. And this is pretty much the simplest possible. I mean, I guess I didn't have to include a login or something, but just to show you, and you can use setup and teardown just like you would in any other test. Now, setup is not included in benchmarks or profiles. It's just the action itself. And so you see here, this is just like integration tests. You're saying, get root and just giving it a URL. And so it's really simple just to be able to, stick in a single URL or stick in a browsing session or cover, most of your app if you want. And then you run tests just like you would test unit, except it's test benchmark now. And the results are, well, just like running tests, except you get something other than dots. And this is something a little interesting here. And you're seeing process time. That's what's usually benchmarked. But there's also memory and objects, GC runs, GC time. What are these? Well, there's this nice little tool, Ruby Prof. It's been around for a while, and it can measure other kinds of things. It doesn't need to just measure process time. Why not measure other things that matter? Things like object allocation and things like how much memory is actually on the heap. As it turns out with Ruby, Ruby has a really slow halting garbage collector, and these kinds of things really start to matter. And they're kind of in the voodoo category because typically people aren't aware of them. Ruby doesn't provide this information by default. You have to run a patched Ruby, and we'll get to that a little bit later. This is an example of the CSV file. I know it's not terribly readable there, but the most important thing is the top line. The measurement, this is process time, so you're seeing 4.57 milliseconds. The date, so you can track over time. In this case, it's showing the get branch and revision of the application that you're testing against. The Rails version, and if you have it in vendor Rails as a Git submodule or a symlink to your Rails checkout. The Rails branch and revision. Here are the Ruby version number and patch level and your platform. So it makes it really easy to do things like try different Rails revisions, to try to do some regression testing and see whether Rails screwed my app up, or did I screw my app up? And so I haven't actually tried using git bisect with this, but it would be pretty cool to be able to identify that way. I can't really git bisect across two repositories at the same time, but in any case, it's also really fun to try with things like JRuby and Rubinius and Ruby 1.9 because you have all the results there and you can start graphing them against each other and get some really pretty stuff that makes you feel good about all the new Rubies coming out. So looking at those big branches, not trying to focus on those individual methods like hash accesses or array each. These are the kinds of things that show up at the very top of your profile results. And the big branches are things like loading the page at all. And it's kind of a trivial thing to step back and look at it, and you'd think, maybe step one would be maybe do some fragment caching or action caching. But it's a lot easier just to say, well, if the page hasn't changed, let's just treat it like assets. And these assets, we put this work into doing these expired headers and timestamps and all this, and it really works well. And we've cut down the load, and when you're looking at Firebug, you've essentially reduced most of your requests, second request and thereafter, to just loading that HTML page, which is pretty freaking nice. And so if you can do the same thing in Rails, which we can, it's just HTTP. And this is really where I've been kind of gratifying, seeing the promise of REST really come into its own. And some of these things with handling conditional Git are really much simpler because of the RESTful nature of Rails now. So if you have a resourceful web application, it becomes a lot simpler to state things like the freshness of a page, and when you're returning a response, to be able to say that this uniquely identifies this page, this is its entity tag, or to say this is when the page last changed. And freshness is it's kind of a crucial concept. It's a little strange if you read through the HTTP spec and talking about these details, and some of it's a little arcane. But freshness is really just this little bit of information that you return from your app, and it gets stored along in the browser cache, And if the browser makes another request, it's going to look and see if it has any freshness information. And this is where the whole notion of conditional get comes from. If it has freshness information, on the next request, it's going to send it. And it's going to say, if you're fresh, just don't send me a response. And the way the HTTP spec phrases this, it's kind of in a double negative. It's if you aren't fresh, don't not respond. And so it's a little confusing because the actual header is sent back. This is what the response is going to look like. This is the freshness information itself. Last modified, you're going to send a UTC timestamp in this special format. Ruby provides some methods to do all this formatting for you. And an E tag is really just any string. And you can come up with any key. It's like you're coming up with a cache key. If you guys have done caching, you can just use something arbitrary as long as it uniquely identifies that content. And so it's a similar situation with the E tag, except your content is the entire page. So we see, okay, this is trying to just kind of naively translate this to Ruby. Say we have this member method on a resource, and we want to send back this information. Well, this is just literally kind of a transliteration of how we can tell the browser what's going on. Well, let's say post updated at uniquely determines the last time that page was changed. And here E tag is very similar to a cache key. And we're using the post ID and updated at, and that's going to uniquely identify it. Then the browser's going to see those, and on the next request, here's its freshness information. It's kicking back to you. Have you been modified since the last time I thought you were modified? Do you still have the same E tag that I thought you had? If you don't, or if this is the condition, if these things hold, then send me a response. If they don't hold, then send me a not modified status back. That means you don't have to send anybody. You're just telling it, hey, nothing changed. It's all cool. And the real promise here is that you just have to do a lot less work to figure out whether something changed. There's actually support already built into Rails. If you look at your application now and just hit reload on a page, it actually computes the E tag for you. But the only way to really consistently do that and to not screw up is to render the whole page and then say compute a hash. But then you have the whole expense of servicing that request. And so all you really get out of it is not having to transmit that request body back over the wire, which helps. I mean, it's certainly, it's not negligible, but we can do better. And ideally, you'd avoid rendering at all. So here, we try thinking, okay, we need to set the freshness information on the response, and then we also want to check to see that if freshness information was sent to us in the request, we need to check those conditions. And so we end up with this kind of, okay, we need to parse the date and then get the E tag and then compare the browser's modified time or if modified since and see if it's later than the last modified time that we have that we're going to be sending back now. And similarly, compare the E tag. And looking at this, it's just like, oh, God. And so we can simplify it. Let's do a little extraction. And so some of those things, we'll just wrap them up in those headers. We can just turn them into methods on the request and response object. It just makes life a lot simpler. Similarly, we can wrap up some of those conditional checks. Rather than doing the greater than directly, we can just ask the request, just tell me, have you been modified? And we can simplify that even further. Let's just ask the request, are you fresh? Is what's in the browser cache, is that up to date? Is that fresh? And if it is, then just return not modified. So it ends up being quite a bit simpler. We still have this bit of wrapping. And there's, if you're in a situation where you have all the information you need to return this freshness information before really the main meat of the request, then you can actually just move it all to a before filter. And so we've simplified that show quite significantly from the first example. All that Chrome and Cruft is gone, and it's a matter of the before filter just doing a simple check. In other cases, you won't have all that information available, and you may need to postpone the freshness check into somewhere deeper in the in your action. And ideally, what you're going to do is look through the action and figure out the first place at which you have that information. And as soon as you do, that means you at least have the potential to stop rendering right there, just to like short circuit the whole process. And so every step you can do to move kind of work past that check means that's time saved. So if you're doing a bunch of find calls batched together just because it would be convenient for your view, perhaps splitting up those find calls would let you save on, say, 5 queries, where you only need the first query to figure out that freshness information. There's another little interesting nit here. I mean, people have been using things like squid for years. I mean, back in the 90s, this is one of the real kind of popular strategies for scaling Perl applications, just to avoid ever having to hit your application backend at all. And this is even more voodoo than browsers, in my opinion. I mean, maybe I just haven't learned enough about it, but I played around with it a little bit, and you have to do things like tweak the cache control headers correctly for proxies, and it really varies per proxy the way it treats your application. And some have these outdated notions of not being able to cache things with a query string on them. Squid actually changed that behavior, and I think it was version 2.6. But I don't think that's really entered into the popular consciousness either, that these caching proxies are really up to date and kind of modern ways of dealing with web application performance. But I think it's be an interesting area to explore, especially with Rails, just being able to put a proxy in front of your application and treat it as kind of a second-level cache. And that brings us back to the next biggest branch. So garbage collection is a really tricky thing. It's been complained about for a long time. If you look back on all the Ruby core lists, if you look back on Ruby Talk, you see people kind of complain. And I remember reading some of these messages and just being like, it's just, it does the job and I don't really ever notice it. And that's enough for me. But when you actually end up looking and seeing how expensive garbage collection is and the penalty it imposes on your web application, it's really quite horrid. I mean, it's really disgusting. And the major problem is that the garbage collector pauses the entire process while it's doing garbage collection. And woe be unto you if you're generating so many objects that a garbage collection run occurs during request processing. You're just going to get entirely screwed. And here's our nightmare scenario. This is an example of the test benchmark where I've made an action that just does a ton of extra work. And here it is. I can see that it's doing 18 garbage collection runs. That's, 1.2 seconds out of 1.3 seconds, and it's huge overhead just because there's a simple oversight that ended up just generating way too many objects for what needed to be performed. But luckily, there's kind of a light at the end of the tunnel with the garbage collector. There are at least some things that we can do. Stefan Case has worked on a patch for the garbage collector that allows us to tune it. And Ruby, over the years, has been tuned for short-running scripts. They're not supposed to be living for a long time, and they're optimized for keeping the total memory heap size down low. And this really doesn't match the behavior of a web application, where it stays up for a long, long time. Hopefully you just don't kill it very often, and you know that it's going to have a larger footprint than the default is only 8 megabytes. And so that default is kind of the threshold beyond which Ruby is saying, I really want to stay below that memory limit. And so often in an application that uses a lot of memory, you're going to see the garbage collector running even if there are free heap slots available for objects, just because it's over that kind of magic number. And so the key here is just to change that magic number. And it seems just, kind of deceptively simple. But there you go. If you look on GitHub at Stefan's repository, there are a few garbage collector patches in there. It definitely does take some extra work to patch Ruby, but it is really not bad compiling Ruby, especially when you see the benefits. We're running this in production on our 37signals apps, and it is just a boon. It's a really easy, nearly free way of speeding up your application. These are some, the variables are kind of arcane, but they're understandable too. And here we see that the number of initial heap slots is the number of spaces that you can kind of stick stuff. If you're creating stuff in Ruby, you need to put it somewhere. And so Ruby starts out with a small number of places to put things, and this is just saying, use more. This is closer to what a typical Rails application will need. And you can see that this tuning, this is close to what we're using, it's actually 60 times more than the default. Again, here, the number of heap slots that are freed after garbage collection means that when garbage collection runs, I want to be sure that that number of heap slots are available for other objects. And so rather than running garbage collection until just a small number of heap slots are available, I want to run until enough are available that I don't have to garbage collect for a while. Similarly, I'm adjusting that magic number. I'm going from an 8 megabyte cutoff, which is the default, up to 60 megabytes, which is close to a mongrel's kind of resident size. And that means that you're actually running the garbage collector when you're going over the expected size, rather than going over Ruby's expectation of what all Ruby scripts should be like. And so this is really, I mean, it's a simple tuning, and I encourage everybody to try it. I would really like to see something like this go into Ruby itself. I received some pushback, and Stefan actually did the original patch back in 2005. And Matt didn't want to include it because it uses environment variables, so there's some kind of security concern, because what if you do something crazy like set this memory cutoff to, say, 1 byte, and you can screw up the Ruby interpreter like super big time. But it's so worth it that it's insane that it has not been included for 3 years. And so here, with this tuning, our nightmare scenario is no longer a nightmare. No GC runs at all. It's just that there's enough space available for that action to complete without needing a GC run during the request. Now, when the request is done and when it finally exceeds it, then it's going to do a GC run. So it's running less frequently, but far more effectively. And you see our process time is down, that's 9 times faster. Right? 3 years old, complain. Finally, we get to the really kind of interesting part to me. And this is what I think is cool as like a framework developer. And it's definitely back into that comfort zone of all the nitty-gritty, the nuts and bolts of doing Ruby and trying to figure out how to make the Ruby code itself faster. It's its own kind of performance exercise that's it's kind of addictive. So we want to figure out now what the next biggest branch of that kind of performance tree is. And at this point, we actually have to finally dig into the app to figure out what's going on. Before now, we were able to look at just things like using HTTP effectively and using garbage collection. Those are kind of like our free speed-ups. Those are things we can do in our application just looking at benchmarks. We don't really need to see where time is being spent in them, because we're just saying don't spend any time at all, which is certainly the simplest answer. And we use Ruby Prof. It's a very fast C-based profiler. It works with most modern Ruby versions. It's actually going to be included in Ruby 1.9 as far as I'm aware. I don't think it's actually been merged yet. But all this stuff depends on, unfortunately, on an unreleased version of Ruby Prof. And so if you want to try it out now, you need to get my branch off of GitHub. It should be version 0.6.1, should release shortly. I was hoping it was before then. But. And similarly, you can use those same performance tests that we developed when we were showing those benchmarks. You can use those same tests for profiling. And so when you run the test profiler, it's going to run through, for each of those test cases, it's going to dump out a bunch of different profiling results. And there are quite a few available, and most of the profiling output is just junk. It's very difficult to understand and work through just because there's so much going on. And there are Ruby methods, there's all the Rails internals, and so this is just digging into this is a much higher step. And you need to kind of gird yourself and get ready, because you're going to see a bunch of junk and just be like, what the hell is going on? And so you need to be patient. And so here, you end up getting a very similar output. By default, I don't profile GC runs or GC time because it's not deterministic, and it's not really interesting to see that GC happened to run during a certain method, because GC happens to run during certain methods. It doesn't tell you much. But this is a good example of kind of the profiler overhead. It's still quite fast, but it's also significantly slower. But it's nowhere close to as slow as the pure Ruby profiler. So it's actually in the realm of being a day-to-day useful tool. You can just pick this up and get results pretty much immediately. So it's going to dump profile results in a file in temp performance that's similarly named to the test method. I typically use, well, you can see that the metric name, process time, is there in the file name. There are other metrics like memory and the object allocations. There are profiles for each of those also. The profiler includes memory profiling and object profiling. So if you're trying to track down a GC problem that hasn't been solved by the previous kind of free solution, you can profile object allocation and see if there's some place in your code where you're just spewing out tons of strings or something, and those strings need to be garbage collected. So if you're careful about object allocation, it's kind of a shame, really, in a sense, that you would ever have to be aware of these details of your runtime. That Ruby should really be doing a lot of this for you. But nevertheless, here we are. Here's our Rails applications, and we're generating a lot of strings. Well, then you can look and see which methods are doing it and try to cut those down, because it's going to eventually save in your garbage collection time. And this is kind of output. And you get this call grind file that you can load up in kcache grind. And you're like, man, that is so Linux. And how does that even make any sense? Like, I can't get any information from that. I mean, and it looks kind of cool because that's your whole page load. I mean, you can see probably over there is routing, maybe over on the other side is some B4 filters. I mean, who knows? But it certainly is cool. So let's try it. Let's take a look here. So kcache grind is actually available on the Mac and Mac ports. You have to run it through X11. Unfortunately, I don't know if there are really any other call grind viewing tools out there. This is a little clunky, but it's what we've got, so get used to it. And so we can see here, I've gone down the list, and these are all the profiled methods. You can see the location, which file it's in. You can see the method name. You can do things like search, say mutex. I can see all mutex calls. The column here on the left, the include, is the time spent in all children of that method call. Self is the time spent in the method call itself, but not children. So you can drill down and see things like this method is actually performing a lot of work itself versus this method is performing a lot of work subsequently. And so ideally, you're going to look for things that have a high value there on the included side, not even necessarily on the actual time spent itself. But you're trying to look for those big branches that you can cut out and just speed up your whole application all at once. So this is where it really becomes kind of a Rails boot camp, and you see all the internals of Rails here, and it's up to you to peruse. But I can go down here and see, let's just pick one. This is actually a method that's in Basecamp, this recent items by project. And here, we're actually getting a little more resolution there on the right. Well, not too much better, but you can actually see some words on it of what's occurring. And the kind of thing we're looking for is that array each, and that means something's being performed multiple times over and over again. So, depending on how many times that's being called, perhaps we can cache that. We could remove that and memcache it or something, and that's 22.57% of the total request time. So we know if we cache that, then we'd only incur the cost of computing the cache key in the first cache instance, and then we'd be saving 20-something% of the total request time. So it's at least easy to kind of go down and spot things that your application is doing that you can speed up if they're already slow. So enough of X11. And that's kind of what we get to. And what we're typically going to see is, especially after you've dealt with your database performance issues, if any, and typically that's kind of the very first round. Everybody's already done that. And the next thing you're going to run into as far as chopping off those big branches is fragment caching. Again, it's just trying to avoid extra work rather than speeding up existing stuff. And so if you're going to be caching partials, you can even cache methods, you can cache whole pages. But it becomes a matter of identifying those things that are cacheable and just don't do that extra work. Yeah, do less. Keep doing less. And so we're in a similar situation, like generating an e-tag or trying to uniquely identify a bit of content. This becomes quite difficult, actually. If I want to cache the dashboard for a user, you need to think about all the things that dashboard can vary upon. And the simple way is just to say, well, cache it for that user. And for that user, it's going to stay the same for all time. Well, the difficulty is that there are other things on the page, other forms of kind of Chrome, other little conditionals in there. You may have things like relative timestamps that are going to change over time. And if you cache it for that user, then they're going to see that same 5 minutes remaining on some little widget, which just doesn't make any sense because that 5 minutes should turn into 4 minutes, 3 minutes, 2 minutes, 1 minute, which means that you should really only cache it for a minute at most if you want that minute countdown timer to work, which means that you have to be looking through all your helpers and all your views to figure out those dependencies. And this is a tough problem, and you will get it wrong. At least I will get it wrong. I should not be so presumptuous. You guys all get it right. But it's quite difficult to go through all those helpers and not miss something. And so this is another kind of fertile area, fertile ground for exploration. Other ways for partials and helpers to themselves kind of tell the application, I depend on these things. I vary based on these parameters, maybe. And then to generate a cache key. Notice that you're within a caching context and use those in the cache key without having to kind of top-down declare them all. This is a really big, it's a change in the way that I'm seeing our applications grow and develop. Because when you want to cache effectively, you notice all the places where you can't cache effectively. And a lot of them are things like having inline conditionals. If you, say, just have showing some HTML, if somebody's an admin, say an edit link or something, or a delete link, typically you're going to have permissions on the other end of that link also. You don't really need permissions on the showing the link itself. You could use CSS to do that. You could use JavaScript to do that. You could just cache that entire page and defer that conditional to another time. Similarly, if you're doing checks within a partial and that aren't really needed, you could do them in the controller. You could do them sooner or later. You should move them so that you have a larger swath of stuff that is possible to be cached. And this, the dash is actually an example of trying to determine when something should change. Say that I'm showing a list of posts and their comments. Well, how am I going to know which last modified date to set there? It's really when any post changes or any of its comments change, or possibly those comments changes might not just be the last time a comment was touched, but the last time one was created or the last time one was deleted. It becomes more that the comment is living within this aggregate boundary of the post. And you want the post to understand that all of its children kind of have an aggregate timestamp too. So what matters is for the resource that you're displaying, you may have an application layout, you may have Chrome on the sidebar, in addition to the actual dashboard itself, and you want to come up with a way of representing the fact that this timestamp means that this page changed. And I've ended up with patterns like this, where if a post has comments, then you'll have the comments kind of touch the post and remind the post that, hey, I've changed. And there are other things that go into this too. Say that you have an account, and the account has a color scheme, which kind of like Basecamp perhaps. And when that color scheme changes, you want every page to change, which means that you need to be aware of when the account changes or when that color scheme changes and include it in every single last modified timestamp. So these are things that are easy to overlook in kind of that naive way if you think of it as just caching the model or just the importance of the timestamp on the model. The real important part is the timestamp on the entity that you're sending back, is the resource that you're presenting. And this is where I kind of started. I thought I'd be talking about Rails performance, but the more I got into working on Basecamp, I started out assuming that I'd be improving Rails. But the more I worked on it, it turned out the more I was working on improving its interaction with the browser, the more I was working on its interaction with the cache. And these things made such a bigger difference to the actual performance of the application that when it really comes down to Rails, and you've almost avoided all the work that you can do. There are some cases where we have improved Rails. I found a couple spots where it was just allocating a bunch of extra memory and just being like, what's going on there? And having the ability to at least look in and drill down through the application and seeing where it's spending time, where it's allocating objects, and where it's allocating memory allows you to actually see where the kind of heavy weightness of Rails comes from. And it turns out there are a couple really simple things. One was capture helpers. If you use div4 with the block form, that's the way that it was implemented would actually take a slice of a buffer and kind of remove it, which means it was generating a brand new string. And so every time you used one of these helpers that had a block form, you were chopping out that piece of the buffer. And so you were creating all these extra kind of unnecessary strings. Well, it turns out to be a pretty simple thing, modulo the wrestling with ERB to remove all that extra memory overhead. And there are a few cases like that where in your own profiling you might see things that are going on with Rails that you like to improve. For the most part, I hope you don't come across them, but if you do, yeah, sometimes it does. Please do investigate. We're very open to these patches because it really helps everybody. If you find these kinds of things, and everybody here in the room is running Rails applications, and if you speed it up, it's going to be faster for everybody. And so please share. And this is really the thing I come back to. And in the original idea of what is a performant application, the performance is what you can do with Rails in your application. The performance is our own performance. And is it still fun to make these applications? We create these little kind of mythical pissing contests with ourselves, to fight this battle. When it's really, we're creating applications for users. And the main driver in performance is just that we were able to do that, and we were able to do it quickly. We were able to enjoy it. And so that's my final standard of performance. So, thank you.